back here. Let's get this running. So what just happened with this? Must have broken RNN somehow. Oh, wait, it's because I forgot about that. Okay. Yeah, I forgot about that. State. You need this actual state, don't you? Right, where is it? There it is. Creator. Agent args. Eek. It's annoying. Args. N of quarks equals N of quarks. That's weird, isn't it? Oh, maybe not. We're just using this to give consistent apply. And the observation space. Try this. Got 3D instead. You do not need num layers anymore. So it's not enough values to unpack. State got it. Forward. So wait, what is this? This state and then hidden comma C. And that's weird. Action state hidden, I guess. Super obnoxious. Agent. What do I do with an eval? Oh, that's crazy obnoxious. Okay. We'll just do this one. We'll just do this one. Because otherwise it's like, it's just too much. And we need to do... This can be none for now. Well, no, it can't be, because I'll get a shape error, won't I? That's super gross. Just grab archive skills. Implementing DA, yeah. It's kind of funny because so far none of these algorithms actually work. Which is like telling. I mean, but what a massive waste of time that is, right? So E3B, whether E3B should work or not depends on whether the math that they have actually makes any sense, right? Whether it's actually an approximation to counts or not. And then, because counts works for some M's, but it's also slow. It has bad complexity. This thing, it seems like this should work, and there's like I'm a little bit more optimistic about it, but it's more obnoxious. It's not just a reward modification. It's like obnoxious to have to deal with. That group sometimes throws unnecessary math on top of methods that do work. Well, really don't need. Yeah, exactly. I mean, that's a lot of people in RL. I mean, this is why literally I consider the majority of research, even from the top labs, to just be wrong. The majority of publications are just wrong. Full stop. But we do have the author of E3B, one of the authors, in the Puffer Discord with some suggestions. The justification for the counts based, the math in this case though was that it's counts based approximation without actually having to do explicit counts, so you can do it way more easily over stuff that's not just like a grid. So it works in continuous space. It works over like skills and actions and market usage, all the other stuff that you'd have in a fancy env. Ugh. Train args. Agent quargs, env args. Oh, you don't have it. Lovely. Some stuff that's to 8. Somehow they're doing research on NetHack at Meta. That's funny. Like RL, or are they just using it for LLM slop? Okay, so here's with this off. The policy, very basic. LLMs for RL agents. Oh, geez. That would be one of your top teams, really? I mean, it's like, I guess if they're willing to throw enough compute at it, maybe. That approach just seems wrong to me, though. Unless they're doing like a fast, slow model thing. Like just end-to-end LLM on like a NetHack seems like a really dumb idea. Industry scale research. Not end-to-end. I mean, the correct method, I think, is what some of the robotics companies have started doing now. I've always said this as well. It's that you have a big model you query once in a while. LM's design intrinsic rewards. Oh, geez. Okay. Yeah, I don't think that works either. That's a rough one. It does, at least on NetHack. When you say design intrinsic rewards, I don't think it's intrinsic rewards. It's designing, like, just game. It's like the LLM does the reward engineering, right? That doesn't have a. Well, but the thing is, like, if that works, that's going to work just because there are no actually serious baselines for NetHack, right? Like if you actually bother really trying to like get the rewards right, and you could actually run the ablations. I think the thing that's way more likely to actually work is like a sort of like fast slow model thing, where you just have a low level RL controller, and then they have a high level thing you can query once in a while. LM scores states based on a given task. LM scores states. Does it score every state? States to make a preference data set. RL scale, not LLM scale. Hmm. And then pure. Well, NetHack is just like a really annoying env because it's like, it's fast in theory, but it's not actually fast. Yeah, no, you'd need an LLM for like specific high level pieces of information not learnable tabula rasa, I agree. NetHack is like a really obnoxious env though for RL because like on paper, right? It's like, oh, it's super fast. It should be great for RL, but it's not actually super fast because there are limitations of how you can run it parallel and whatnot. At least faster. No, it isn't. That's the problem. No, it isn't. Like even ProcGen is faster. And that's with image obs. It's actually incredibly slow without my vectorization as well. Without a fancy learning library. No, even with it. So with a fancy learning library, I can bring it up to 100K. So like, where's this? This is old benchmarks, right? But yeah, so it's like, it runs like 7K on Gymnasium or SB3, single core even, and then same speed multiprocessed. You get up to 18K single core with Puffer, or where is it? No, that's on a laptop. So you get like 3x faster, mind you, with Puffer, and then you get up to 96K on a decent machine. But like, oh, and mini hack's even slower somehow. Um, ProcGen, I think I got to 30K or something, and then 150K with pooling. NetHack doesn't benefit from pooling. No, it's slower than ProcGen. So this would be this is the best metric here. You compare best. So it's like substantially slower than ProcGen, and mini grid, and it is a bit faster than like Atari, for instance. I think I got this number up a little higher, but it is a bit faster than Atari. But then also what ends up happening is as soon as you train on it, you lose all that perf because of the way the observation space is. So what you'd have to do is you'd have to take like the image wrapper version of it, actually make that fast, and then you'd have to feed that into a more standard net architecture. It's not like easy to make that fast out of the box at all. The other issue is it just doesn't scale very well because okay, look, this 96K looks very good on paper, right? But the thing is, it doesn't scale to larger batches very well. So like when you would want to have a larger batch size, it doesn't scale that well with NetHack because you need separate processes. So it's misleading is the problem. Complexity per SPS env out there. Um, it would be a good env if there were actually some engineering put into prevent you from losing all that speed as soon as you try to use it in an RL context. Because like the base game is really fast, but you lose all the perf going to an RL context. If that makes sense, right? And it doesn't matter if it's like the best at like SPS per complexity. It's too slow to be usable is the problem. It's really too slow to be usable. It's very close. Like there's, I think with a bit of engineering, it could be very, very good. But at the moment, it's too slow to be usable. Okay, what was this? This is 39. And yeah, it's like, okay, it's faster than, the heck? It's faster than what came before it, but the thing is, the majority of research is, of like RL research is just hard trolling. So like, that bar is so low you have to dig for it. It's expensive, but you can do research. There aren't any similarly complex than that absolute. That doesn't make it complex though. That just makes it not learnable tabula rasa, right? I can just say, hey, read this text and give you like a pixel rendered image of text, and that's not going to be learnable tabula rasa either. So that just makes it like not self-contained, right? It's the search space into it. If I renamed like Medusa to something else, right, you'd be screwed. Action is, it's not that. It's like, the thing is, look, if you already know how to solve a problem before you've done it, like, it's not a good problem as a learning benchmark. Like this is not to the credit, right? This is not a credit. Like if we replace Medusa with like some other like just random string or whatever, like you're not gonna know to wrap a towel around your head or use a mirror or whatever, right? It's a very, very rich sim, but I don't think it's like because it needs an LLM, it's complex or whatever, or like the reasoning is hard. Um, well, no, the point here is it's not arbitrary scrambled grid worlds, right? Real world. I don't know. There are a lot of industrial processes where the real world knowledge is very obscure. And like, yeah, you can bring an LLM into it for sure, but like, you're kind of muddying the problem in a bit because you're massively increasing the compute requirements without making any fundamental advancements to RL itself. I mean, still, if you solve the game, that'll still be a massive, massive breakthrough, right? Because I don't think the game is solvable tabula rasa. Um, but I still don't think it's going to solve the game for quite a while. I mean, I could be wrong because like the Pokemon result, NetHack is much harder than Pokemon, but that just worked with like a little bit of scripting. To be fair, a fair bit of scripting. But the thing is, you're missing the point here. I don't care if it's a class of problems that tabula rasa can't reach, because the LLM side of research is going to happen anyways, right? Like, there are thousands of people fiddling with LLMs. Like, that's going to happen regardless. The side of progress in science that's not guaranteed is the RL side, because nobody's doing it. So if we're looking for like potential bottlenecks, like, hey, where could AI get stalled for the next 10 years? It's because nobody's done RL. Using LLMs to make RL agents better. One of 3 labs. That's fair. Yeah, that is fair. I think that what is going to happen is the, like, let's run RL on an LLM will happen. Yeah, that's fair. Yeah, I mean, that's like a decent problem space then. I still think that like the major issue at the moment is the RL side's really screwed, right? Like, I think that the amount of LLM specific stuff required is very, very small, and the amount of RL stuff required is very large. Trying to find it's just because it's expensive. It'll happen. It's just because it'll happen. Yeah, but the thing is, right, if you agree with that, and it's like legit because there's nowhere in industry doing just pure RL. But my vision, right, is how do I make sure that the field of AI doesn't get stuck because like people just didn't bother actually pursuing this incredibly promising branch of science, right? That's what's happening with RL right now. Is that just like, why is it that I can make all these crazy things happen in Puffer in less than a year, right? I'm one guy. I don't have a massive team behind this. I have a few open source contributors. Um, I haven't been writing C for 10 years. I haven't been doing any of these things. It's just nobody tried. Like, nobody actually tried. You say, oh, well, there was a lot of RL publication. Yeah, but it was hard trolling. Like, if you're training at 900 steps per second half the time, and you don't run any ablations, and like you don't try obvious variations of standard methods, right? And you do publish fancy algorithms that don't transfer to any other M's other than the ones you tune them for, you're just hard trolling. So that's kind of what the field's done for the last decade. Feels like this algorithm should work. I mean, it's not just slop, it's just like completely invalid science. So like if we rewind the field to like, roughly when Dota happened, and if you assume that there's been like no serious progress, maybe a little bit, but mostly no serious progress in RL since then, and you see like the curve of like how quickly RL progress was being made until the stack got too deep and stuff got too slow, it's like insane to have dropped, right? To drop all scientific effort in this area. And that's what's happened. So that's why like I'm like so like laser focused on just pure RL. It's not because I think it'll solve everything on its own, right? I think it'll solve a lot of industry problems which are really like not superhuman readable. Manufacturing optimization problems, stuff in games, maybe stuff in animation, just like tons of random things all over the place. Tabula rasa RL will do, it'll do enough to make a viable business and to improve a whole bunch of areas, right? But then in general, I think it's this really important thing long term, and it ain't gonna happen if I don't do it. That's why I'm stuck on this. And this is a casual 2 million step per second run, not even fully optimized. Keep beating my head against exploration. Filtering down the search place. Well, the first problem to address here, right, is that exploration is a fundamentally horrible and broken area of RL that has never been defined properly. And we need to stop testing that on like very human intuition coded problems. I actually like this diversity is all you need method. I like the idea of training policies to do recognizably different things. That seems like something very natural. By the way, you could very, very easily do diversity is all you need, but with LLMs if you wanted to, right? Just instead of training a discriminator, you would just ask an LLM, are these things doing something different? I'm sure that there's work on that. Isn't that like omni-adjacent or whatever? Yeah, there's work on that. But this core sort of method seems interesting. All exploration bonus work was tested on... Yeah, but it was all stupid as well. Like, if you just, like, think through the method, right? It's like random network latent space stuff. That makes no sense. That's just, like, you getting lucky that, like, some very, very base con features kind of generalize. So that doesn't make any sense. And then there's count-based stuff, which is like, okay, that's really limiting. The E3B stuff is kind of cool, but still counts is not amazing. Like, you don't want to be counting states. That's not a form of exploration. Some of the curiosity stuff kind of makes sense, but the whole world model field was a mess and never got tied together correctly. And then maybe some of the diversity stuff is kind of okay, even though it didn't really fully work, right? R&D, no, it's not. R&D gets murked. Yeah. Where is it? R&D gets murked. Okay, fair. I thought this was... Wait, I thought this was multiple. Maybe I'm being stupid. Is this one env? I thought this was more. This is Mario, and then you have... here's mini grid. Here are a whole bunch of other mini grid M's. I may have reviewed it. That's funny. But they have a bunch of them here, don't they? Here's ProcGen Maze. Actually, does R&D do better here? No, it's 2 and 2. 3 individual M's as sketch. Not all of... Yeah. I still think it's a stupid method longer term. Because again, like on the pixel M's, you're just exploiting like comms recognizing similar pixels. I think the research is basically invalid for all the reasons you hate. Do we think it's invalid to the point that R&D is actually better, though? I mean, I guess I'm biased here because the results are directionally in the favor of the thing that I think would be likely to happen. I don't like all the like random latent stuff. That doesn't seem like a good direction of research in exploration to me. Intuitive methods more. Well, it makes sense that counts works. And counts consistently does work. Like, if you actually just use straight counts, count just works. One policy to be at multiple levels. You can do that. Here's another paper. Let me see this one. Okay, from Epsilon Greedy. Bonus based. Yeah, no, you're right. The counts methods work on grids. They work on grids, right? Worse than R&D in general. R&D doesn't work on Montezuma's Revenge either, though, right? Well, yeah, that's why I don't think that the bonus-based methods are a good direction either, right? I thought R&D doesn't do very well on Montezuma's Revenge either, right? Am I wrong there? I guess I could see it doing kind of okay, because it's like sort of the ideal test case for it, right? It's like exploiting pixel-based sim. I kind of like the diversity is all you need stuff. And I'm kind of interested in like not rollout in latent space, but possibly like next date prediction, like world model style stuff. The other so diversity, like interpretable diversity is one flavor of exploration that makes sense to me. The other is like in the absence of progress, act so as to minimize your uncertainty is the other form that I like. Unsupervised skill. No idea. Well, we'll have to see whether this paper actually works or not. So I like the idea of training interpretably different policies, right? If you can do it without splitting data across multiple different sets of weights, which this method does do, but the question is, does it actually do it well? So far, I haven't been able to get it to work. Yeah, but something's weird here because it pushes the discriminator loss is like 0 instantly. E3B stuff working? Nope. I've tried E3B a ton of different ways and it doesn't work. At least not consistently. Here, let's see. Yeah, so here are all these different runs, and they all collapse. Yeah, these runs all collapse. This is the exact domain it should be good on as well. Nothing works. Well, none of the existing very poorly conducted RL research works. Buffer stuff's been going pretty well. We got Breakout down to like 90-second solves. And that's our version of Breakout, which is fast but doesn't have frame skip. So, not bad. And obviously, we're not just trying to do Breakout forever, right? We have other ends. But it's a nice like hyperparam tuning benchmark. That and Pong. And I have more algorithm stuff cooking too. Really hard MSO. Well, I mean, I'm doing algorithm dev actively, right? Do something. I don't know if it's we obviously need to do something. Well, the field in general isn't doing anything, right? The field isn't in general isn't doing anything. Um, the other thing that's like clear to me is that the algorithm should be able to learn to explore. And like it shouldn't be you must learn to explore. Like it seems to me like a good learning algorithm should learn to explore if that is a good way to maximize reward. Exploration. Mm. I need to look at it more. DeepMind has so much freaking math and everything. Loss entropy. Loss. I don't know how this loss is like 0 instantly. That seems like that's a problem. Future work section, thinking about curriculum learning and LLMs. Sure. Well, it's not so much that I hate it as much as it's like it seems lazy to me to be like, ah, well, we need LLMs to solve everything now. Like literally the difference between RL and language model land is just billions of dollars of investment of people like actually trying to solve stuff. Like the fact that I shouldn't be able to make progress as quickly as I have made progress in PufferLib, right? If the field were actually trying, one guy sitting here should not be able to be like 100xing speed on a lot of stuff overnight. Yeah. I mean, it is incredibly lazy, and a lot of the new researchers that have gotten into, LLM style research are literally just writing for loops over LLMs, right? It's incredibly lazy. You're like 3 people worth of engineering. I mean, I try to be more than 3 people worth of engineering, but that's just like, I mean, that's just skill issue, right? It's like you put more time in, you get better. I'm way, way, way better than I was a year ago. 3 good people. I mean, I don't know. I worked like 2 people's worth of hours probably. Uh, but I also have a bunch of other stuff on my plate, right? I'm trying to build a company. I'm trying to organize stuff around Puffer. here's the crazy thing about that as well, right? Like, if you look at the code I'm actually writing, a first year undergrad can like read and understand the neural MMO3 code, right? It's if statements and for loops in C. That's it. So like I'm not even doing some like crazy advanced fancy thing that you need 20 years of industry experience to do, right? That's on them, right? That's skill issue. That's like if you're not willing to learn the thing that you need to learn in order to solve the problem, you don't actually care about solving the problem. You don't need a big team. Like look how quickly these things get built. It's one file in C. I think a very big problem in academia is people don't actually want to solve the RL problems. They want to do science, right? And like sometimes the way to solve the problem isn't to do science, it's to do engineering. But it's like if you care more about doing science than solving the problem, you're not going to solve the problem because you're going to trip and fall and break your shins as soon as you hit an engineering roadblock. Knocking out awesome new feature. Yeah, you can do that. Heck, you can do that in C as well. It's still fast. I still don't know why this doesn't work. But I think it has something to do with this gloss. Gotta finish thesis? Yeah. Best of luck. I spent like 3 days on my thesis. I do not suggest spending much longer. So yeah. All right, let's see if we can actually fix this algorithm. Um, this is diversity is all you need. Exploration method. It works by encouraging the policy to condition. It conditions the policy on a random vector, and it tries to make it learn interpretably different policies. Background's killing me. I don't want to write Sutton. You don't need to look at my thesis. It's online. You don't need that much background at all. You don't need to write Sutton and Bardo. All right. And the loss for determining diversity is all you need here. It tries to predict what behavior you were trying to learn, I think. Which is right. Where's the loss? Yeah, okay, it's right here. DIAY and discriminator of hidden. And then hidden comes from here. STM state and hidden. Let's see. Which is, as it comes out of the policy, it's that vector. It's very, very weird to me that this is easy to learn. So easy that it's like learned instantly. Maybe it needs to stop, Brad. Maybe it needs to stop, Brad. Hang on, let me think about that. Detach. I wonder if that would do it. What about this? Ah, that's something. That is something right there, for sure. I wonder if how they did it in the original, but this would make sense to me. Oh, wait, but you can't do this, right? Because the whole point of it is to... I don't think you can actually do it this way. The whole point is to change the policy to produce more interpretable action outputs. But that does mess up the loss here. So it is the fact that you can differentiate through it fully that makes a difference. I mean, it's... You should really just be looking at the action, shouldn't you? But then that is not... Hmm. You see that instantly optimizes right there. Instantly. Kind of surprised the original method apparently works. Hang on, this is st plus 1 with just compute q z given st plus 1. Sample action from skill. Wait, is this multiple policies? Okay, this is somehow a whole bunch of code. In TensorFlow, lovely. Z1 hot. Obs, actions PL, reuse equals true. Get distribution for obs PL, reuse is true. I forgot what a mess TensorFlow was. Sample Z from P of Z. Using probabilities in self P of Z. Just trying to see if they did anything in this code that's not like clear from the paper, but it's TensorFlow, which is annoying as hell to read. Interesting. Okay, so this is where you make your observation augmentation here for this new one hot that you add on for the skill vector. Log softmax. See how I did it here. It's the same. Oh. Log softmax.gather. Same thing, right? Evaluate. Okay, so all the logic for this algorithm has to be here. Get output for obs and action PL. And then this is mean. Yeah, so this is mean of cross entropy of the output of this discriminator and then the one-hot augmentation vector, right? That's fine. So then what are the remaining questions here? Discriminator get output for. I guess the fact that the network isn't shared. Oh wait, how does that make sense? Hang on. How does that make sense? So your goal, wait a second. Your goal is to adjust the input policy network to be discernible. And what's actions PL? Oh. Hang on, I might have it. I think I have an idea what they did. This is a placeholder. Where's this get filled? Critic update. Get output for actions. Batch of actions. Is this the log probs? DA, I assume, is the dimension of the action space. Get output for. Q function get output for action PL. So you directly have to optimize from action space, I guess. The action probs. Let me try that. Let me try that. So I think then that what you do is, instead of returning hidden here, we do decode actions. You just return actions, don't you? This becomes actions. Now these are probabilities. And then this discrete encoder is self.num actions to 32. Oops, hang on, wrong one. It's, where is it? Oops. Totally wrong network. It's this one that you have to modify. This is actions. Instead of hidden, right? Or do you need state? No, you don't need state, you just need actions. This is where you collect it. And then this one here, so actions. Presumably you record. There. Okay. We run this. Cannot be multiplied. Discriminator of hidden. Okay. This is still 128 dim somehow. The snake policy. Oh yeah, I forgot about this tactics. Somebody should finish that. Just intermediate. How is this getting screwed up? Policy. Directly calling policy. Ah, this is it. Right there, right? Decode actions. Yeah, that's screwy. Action. This returned action and value. Okay. Value equals this. Return action value. Action. Didn't see. It's a little awkward. Seriously, how's this still screwed up? Hidden here. So that works there, and then it doesn't work later on. In training, it screws up. Because where does hidden come from here? Or train, okay. Ah, you did it here. Yeah, okay. Action value, action, state hidden. Oh wait, action value, state, then it's action. Messy, bad code, but this is just all prototyping. I mean, there's a little bit of lost. Tiny bit. And it's gone. Yeah, I wonder how it is able to do that. Isn't that way better than before? Oh, are we crashing? Yeah, we're crashing. Still though. Let's see. Do we see any noticeable differences? Okay. Here you have various different snakes. You have some of these going to the left and some of these going to the right. Which is interesting. Okay. I still see some going to the left, some going to the right. This looks very similar. These ones are going down and to the right, aren't they? Is it just me? No, these ones are definitely going... Hold on. This is something. These ones are going down and to the right. And these ones are going up. Okay, the algorithm works. The algorithm works. That's kind of cool. This is definitely conditioning on the policy. It's honestly pretty damn cool. So I guess we gotta now run some sweeps on this, right? And then is it score? We have score on this. Death, okay, and now we need to do 7, 8, 2, 8. So these coefficients here. I think I added these to default. No? Yeah, I did. Okay, yeah, so it's got to be a min of 2. Loss coefficient. Form, and then log normal on this coefficient. And log normal. There we go. And this should work. Very nice. Let's go get our other box booted up and let's see if we run some experiments on this. Let me just send over a quick message as well to the person who asked for this. What's the best way to log special events? let's go log into the new machine, the other machine. Office 4. Nice. For tank. Oops. Oh. Yes. Neptune. This will ask me for credentials. This is kind of cool that this actually does work already. Makes sense. It's odd that the loss was so, well, I guess it went back up at the end, didn't it? Oh no, it didn't. Okay. Key error mean. Really? Okay. Min, max, mean. There's something silly? I don't think so. Log normal, uniform. Uniform how to. Is there not a uniform key? Uniform how to. Log normal, log it normal. The hell? Key error mean, so it says it doesn't have a mean? Oh. I see. Let's fix that. Min, max, mean, and scale. Reward for food. Mean is 0.1. Reward death. Mean is -1. Scales auto. And then what's this? Reward food, reward death. That's it, right? Reward corpse. We don't sweep this. Reward. There we go. That's fine. Oh, and did you do num ems? I don't think I did. So I should fix that. Let's do 1, 2, 16. Mean is 16. Cool. So we pull this, and hopefully now we can set up our sweep. Lovely. Well, we'll see how that goes. It's not going to take long because it's training at 2 million steps per second. So that's pretty well set. Cool. That's most of what I wanted to do today. It's kind of cool that it actually worked that quickly, that it does at least something. This is one of the ones where I think there is actually a genuine possibility to improve perf using this. I don't like that it adds more hypers and more complexity, but we'll see. Maybe it's worth it. I'm trying to think if there's anything else I want to do right now. Not really. Let me see if there's anything to answer, and then because I have a couple quick calls to make as well. Double check my experiments real quick. These are running. This one doesn't work at all. Unfortunate. Real quick, can you explain? Yeah, I can do that. Oh, that's solid. This is already doing stuff. Lovely. $1.8K now. So this is the grid shader right here, right? It just loops through. It has hard-coded 4 bots, right? You get the position of 4 bots and the color of 4 bots. So it loops through. It checks how far in world space, so not in pixel space. This is the coordinate in world space of where the current pixel is. It checks the distance to the current bot, and then it scales the magnitude of the color based on that distance. So it's just 9 divided by distance squared. So that's going to be 1 when you're 3 units away, and then it drops off from there. This is the main bit of it right here. Very short. And then it's just defined in your types, and then it gets initialized in. How did you get it to only affect the small grid though? Oh, yeah, that's easy. You literally have a begin shader mode. So when I draw the small grid, begin shader mode. Shader only affects stuff inside of the shader, begin shader and the shader draw calls. Anything else? Bloom is a little bit of a harder shader. If you you should go look up like how to make a proper bloom shader. I draw what I want with bloom. So, but the thing is, bloom is a post-processing effect. The tricky thing about bloom, right? So this thing, right, this shader only gets applied to the pixels that are rendered by this. But with bloom, you have to render like this halo effect outside of the pixels that are drawn by the line, right? You don't want to render bloom on the line. You want to render it like as a halo. Okay, so that's why it's a post-processor effect. And for post-processors, you can look those up. Normally you apply those like here. They have an example. So they have these examples here, right, where they apply these shaders. But the way that they apply them, right? So they draw everything, they draw it, and then they do the shader on top of everything that's already been drawn because they draw it to a buffer and then they draw the buffer to the screen with a shader. It's harder with bloom because you only want to apply stuff to the projectile layer, right? But if you draw the projectiles, if you draw the projectiles in a separate layer and then you add bloom to them, then you need to know what the depth is of the projectiles in case they're behind stuff. So it's a little tricky. Now the good news on this is bloom is like a really, really common effect. So you can probably find a good tutorial on how to do it. I didn't get that far. It's annoying because it's a really common effect and it's like pretty damn important for bullets, unless you're gonna fake bullets. You could technically fake bloom by like just having it baked into the model. That might be easier if you want to get model bullets and like figure out how to fake it into there. You could do that as well. But otherwise, yeah, it's a whole post processor setup thing. That's the tough part. Yeah, so here they do it in two separate layers. Yeah, they do it in two separate layers here, I guess. I don't even think this is enough because you do need to check depth. So I don't know. I think it's a bit more complicated. Anything else I can help you with? We'll figure it out. Thanks. Yeah, it's a little tricky. So the simple version, right, is you just draw the projectiles to a separate texture and then you combine them. But then you still have to handle occlusions. So I think that what you do technically is you keep like a Z layer, right, of like what's actually on top. You might not have to be fair, now that I'm thinking about it, because it might be enough just to do like the two separate layers thing, because I think that you already kind of get the Z information by what you're drawing. I don't know. Anyways, I gotta go do some stuff. I will see you around. Best of luck, Captain. And for the couple folks still watching, all my stuff's on puffer.ai. You want to help me out for free, start the GitHub, join Discord if you want to get involved. You can follow me on X for more content.